Good day everyone. Today I'm going to share my insights about the topic that we've tackled in Prelim Week 1, which is all about Earth coordinate system, latitude, longitude, DLAT, and DLOM. And also in Prelim Week 2, which is all about different types of map projections, the charts produced and their particular use, and the use of navigational chart according to its scale. And lastly, in Prelim Week 3, which is all about general information obtained from the navigational charts, including its symbols and abbreviations. Earth or geographic coordinate system is a three-dimensional reference system that locates points on the Earth's surface. The unit of measure is usually decimal degrees. A point has two coordinates values are latitude and longitude. Latitude and longitude measures in angles. It always be measures in angles. So latitude is defined as the angle formed by the intersection of a line perpendicular to the Earth's surface at a point and the plane of equator. Points north of the equator have positive latitude values, which points south have negative values. Latitude's values range from negative 90 to positive 90 degrees. Lines of latitude are also called parallels because a parallel value of latitude forms a circle parallel up to the equator. So we also have a meridian or line of longitude is formed by a plane that passes through the point and the north and the south poles. The longitude value is defined by the angle between that plane and a reference plane. The reference plane is known as the prime meridian. The most common prime meridian passes through Greenwich. Let's proceed in DLAT and DLOM. In finding the DLAT, we need first to determine the given. Lat 1 or the previous position and Lat 2 is the current position. Then after, we are just simply going to subtract the Lat 1 and Lat 2. So we have here Lat 1 equals 17 degrees 45 minutes north and Lat 2 equals 15 degrees 15 minutes north. We will just simply subtract Lat 1 from Lat 2. So our DLAT here is 02 degrees 30 minutes southerly. Why is it labeled as southerly or south? It is because the vessel is proceeding downward or heading to south. That's why it is labeled as south. We have here another example wherein Lat 1 and Lat 2 is in the opposite direction. If the previous and the current is in different location, we will add them. So the result is 12 degrees 45 minutes southerly. We will label as south or southerly. This because the vessel is proceeding downward or heading to south. Let's proceed in finding the DLO. Same steps wherein we're going to determine the given or the current and previous position of the vessel. We'll subtract the long 1 and long 2 so that we will come up with the DLO. So our DLO here is 030 degrees 18 minutes easterly. The label of our DLO here is easterly. Is it because the vessel is from the left side is proceeding to the right side, which is in the right side is east. Always remember in writing the DLO or longitude, it should be written in 3 digits. For example, 038 degrees. Here we do have another example in which we do have opposite side of longitude. Remember the rules. If they are in opposite side, we are going to add. So our long 1 here is 110 degrees west. Our long 2 is 080 degrees 0 minutes east. So our DLO is equals to 190 degrees 0 minutes east. But we're not yet done since the maximum value of DLO is only 180 degrees. So we will subtract 360 from the DLO. So our answer is our DLO is equals to 170 degrees 00 minutes westerly. It turns now westerly. It is because we take a full turn in which we subtract our day log from 360 degrees. So now, let's proceed on types of map projections. There are three types of map projections. First, you have cylindrical projections, conical projections, and azimuthal projections. In cylindrical projections, these are rectangular or oval shape, but this projection technique is a very variable in its shape. It have lines of longitude and latitude at right angle to each other. Also have distortions increasing away from the central singular line. Have very small directions along central singular lines, and it also shows shapes correctly, but size is distorted. The second type of map projections is conical projections. Conical projections are fan-shaped when used to map large areas. It has very small distortions along the central singular line, and its shapes are shown correctly, but size is distorted. It is usually have lines of longitude fanning out from each other and have lines of latitude as open concentric circles. The last type of map projections is azimuthal projections. Azimuthal projections have distortions increasing away from the central point, have very small distortions near the center point of the touch point of the paper. Compass directions is only corrected or correct from the center point to another feature, not between other features. It is azimuthal projections are not usually used near the equator because other projections better represent in this area. Map projections relies on basic projections techniques. It describes the way an imaginary piece of paper is laid on the earth to obtain latitude and longitude for the map. Basic projection types presents equal area, in which it correctly shows the size of the features, and then conformal correctly shows the shape of a features, equidistant, in which it shows the distance between two features, and lastly the true direction, in which it correctly shows the direction between two features. Let's proceed on general information provided by the nautical chart. In nautical chart, it shows the title blocks, chart notes, water features, use of color on charts, lettering styles, land features, characteristic of the sea bottom, features of the shoreline, and man-made features. In title block, it includes information like title of the chart, projection use, original authority, units of measurement, date of survey, plans of references, datum for something. In chart notes, you can observe the regulatory restrictions, cautions and warnings, unusual magnetic conditions, depth of channels, and extreme of tidal stages. In use of color on the chart, every colors are always used to distinguish depth or shallow water, shoal water, land areas, and traffic separation scheme. Colors that been used are the following: black, blue, green, white, magenta, gray, and BGL. In lettering style, there are two types: vertical and leaning or slanting style lettering style. In vertical lettering, we can observe there the dry at high water, navigational aids, and drag. In leaning or slanting lettering, we can observe the submerged and floating hydrographic features, tidal streams, rock or reef covered at high water. In water features, always check the title block for unit of measurement, datum used for sounding, and contour lines or depth curves. In characteristic of the sea bottom, it refers to the information of the composition of the sea bottom, just like sand, clay, mud, sandy, rocks, muddy, coral, or rocky. In features of the shore, it is noted as symbols and abbreviations on the chart. It includes informations like steep coast, marshy areas, rocky coast, vegetations, and cliffs. Land features, these informations are important or useful to navigators in establishing vessels' position, directing vessels' movement. In land features, it shows information includes mountain peak, headlands, and shores. And lastly, man-made features, in which it is divided into three categories: water surface, above water surface and below water surface, and on land. In above water surface, it includes bridges, overhead power cables, cable cars, piers, and oil platforms. In below water surface, it refers to submarine cables and pipelines. And on land, it refers to tower, wharfs, tanks, dry docks, and breakwater.
That's all, folks. Thank you.